All right. Oh, my jacket on. Cold this morning. So we're going to do conditional probability. That's it for probability. We might learn matrices depending on how our schedule unfolds. Like I said, y'all, being my 7 a.m. class, I don't have you much longer besides test days. So we'll see how we'll work that out. But tomorrow we're going to work on our practice test for our state test. And for 7 a.m., I'll post the answers for y'all, since I won't have an extra day to go over the answers with y'all. Okay, so you'll at least be able to check your practice test that way. But the other two classes, I'll have another day with them, so I'll do that with them. Okay, so conditional probability. This one I can definitely get okay with, because there is a particular word inside of each problem that gives you the red flag or the hint to do this formula. Okay, and that's that word given. So conditional probability is probability that one event happens given that another event has already happened. Okay, that given word is a token word that we're going to be looking for in problems. Okay, two events have to be dependent, of course. There's the definition of dependent events from the last thing we were doing. And we have this is how you would say it, the probability of B given A. The probability of B given A. It looks like a straight line going down. Let me rewrite it again without all the extra drawings with it. So it's just a straight line. Probability of B given A. Okay, so there's a formula that goes along with it. The probability of A and B happening at the same time over the probability of A. Okay, so a lot of times this can get confusing because a lot of people are like, well, wait, A, I want to put A first with the probability of A given B. But it's B given A, but I kind of look at it as A that over here kind of looks like it's in the denominator. It's not, but it kind of makes me think that. So then I always know that whatever the last thing that's written over here is going to be what's underneath here. Okay, that's just kind of my way of remembering it. You can come up with another way, but we'll be looking at all types of questions with that. And I love to use charts for these examples. So they'll go through like the probability of that you get a 4-year degree and you're a female. Okay. So they'll say like the probability that you get a degree given that it's a female. Okay. So we would do the probability of a female 4-year degree divided by, what did I say last? Female. Probability of female. Okay. So So they'll use a lot of charts for these. And that's exactly what this first example is. Okay. So table shows students by gender at a 2-year and 4-year college, graduate students of 2005. That's when I graduated high school. You pick a student at random. What's the probability that it is a female given she went to graduate school? Okay. There it is. All right. So first, I would look at, and it might be easier to keep it like this, where the words are, instead of making it A's and B's. Is it more writing? Yes. But if we look at it and say, well, the probability that it's a female given it went to graduate school, we're first going to find the probability that it's female and graduate school. Okay? All over my last one, which is graduate school. Okay? So, what number are we looking at that it is a female and they went to graduate school? I know it's small.
1,954.
What did you say?
1,954.
Yeah, 1954. Okay, so I am interested in a female and she went to graduate school. Okay. All over the probability that someone went to graduate school. $3,300 or 3,033. Is that what you said?
Yeah, 3,300.
Is that what you said?
Yep.
Okay. And then let's divide that out. Where's my calculator? And how did you get that 3,303?
Added female and male.
You added what?
Female and male. For graduate school.
Right here?
Yeah.
Okay. So about a 59% chance there. Okay. Yeah.
When we do percentages, are we supposed to round to the nearest whole percentage or no?
I won't be picky unless I specify in the directions.
Last time we always round it to a whole number.
Yeah. I'm not counting off on your homework if you round up to the nearest whole number or if you keep a decimal or anything like that. Okay. Go ahead and look at part B. Whoops, it's definitely not October. Alright, so we want to know the probability of going to a 4-year college. Oops. Oh, as I erased something that was hidden there. Isn't that entertaining? Let's try that again. Probability that you're going to a 4-year college, given that you are a male. Okay? So first we want to find the probability that you are going to a four-year college and you are a male. What number is that? Do what?
4324.
4,324. Okay. Over the probability that you are a male. So in this case, this one's different. We now add up our males. Oh, that's so loud. Sorry, guys. Okay, 7,539. Okay, and if we divided those two out, we should get about a 57% chance. Okay. So like I said, I like how these are set up. That's my formula coming out in me. Okay, the formula mind coming out in me. The fact that I see the word given, automatically, I can use that formula. Okay, that's why I really like these problems. Any questions so far? Okay. Let's try that one. All right. Who thinks it's A? B? C? D? D is correct. Okay. So if we're looking for the probability that the sample of recycled waste is paper, we should have a 57% chance. Okay. Sometimes I think the tables help. It's very visual. It's right there in front of you. So definitely take advantage of those. Okay. Any questions? Okay. That one's cut off. We'll skip that one. Okay. So if two events are independent, my words right here. Two events, sorry, the if is gone on yours. Two events are independent if the occurrence of one event does not change the probability of the other event happening. Okay, so we said originally that if we're going to do conditional probability, that it has to be two dependent events. Okay, well, what if they give you two events and they say, are these two independent of each other? Okay, and you're going to figure out how to prove that. And so we're going to look at if you do the probability of A given B, but then you end up with the probability of A. Okay, that makes it independent. And if you do probability of B given A and you end up with just the probability of B, then you run into that issue as well. Okay, so we're going to do an example like that. Okay. So let's look at our first example of that. Are the events of male and left-handed independent? Okay. So first I want you to look at the probability that it's a male given they are left-handed. Then I also want you to do the probability that they're left-handed given they are male. Go ahead and find both of those. According to our formula, this one you should get the probability that it's a male, and then this one you should get the probability that it's left-handed. If you don't, then they're dependent. Okay? So let's look at the first one. So I want to do the probability that is male and left-handed over the probability that they are left-handed. And if it equals the probability that they're male, then it's independent events, okay? So, probability that it is a male and left-handed is what number? 7. Okay, over the probability that they're left-handed, this table is real nice because they do the totals for you. Okay, not that y'all can't add 7 plus 3. All right, so 10. All right, and let's check out the probability that they're male. Okay, so what's my probability that they are male? 46 out of 100. Are those equivalent? No. So these are dependent events. Okay? That's how they want you to prove. It's kind of like when we did f of g of x and g of f of x. Okay? Remember how we had to do both to prove if they were inverses of each other? We got x in the end. Okay? This is how you will prove if they are independent events or not. Okay? And it'll definitely turn out in some cases. We can kind of see by the chart on this one that they are dependent events because I have a male that is also left-handed. But you get the point of the proof part. Okay? Any questions? Okay. Let's see if I had. Let's go back and do a little old school probability problem real quick. Yeah.
So is it like you grab that two at the same time? Or you grab like one, and then you grab the second one?
You grab, I mean, it could be one at a time, but notice how they're not saying you put that other one back. So whether you grab them both at the same time or you grab one at a time, you're still going to look at that same probability. Now, if they specify you picked one up and you put one back after you did that, then that changes your probability. They like to put with or without replacement. They'll put those words exactly. All right, so what's the probability that maybe the first sock or one of the socks is red? Do what?
37.5%.
No, just the probability of oh, you went ahead and told me a percentage. Yes, okay. So 6 out of 16 chance. Okay. What's the probability that the next one's also red? I've already picked up one. 5/15. So if we multiply that together, oops. Okay, so 1/8 or 12.5%. Okay. All right, so that's when they start throwing in the old probability problems when after you just learned a formula like that. Okay. Any questions? Did not think I was going to get through that in 30 minutes. I was doing it in y'all's class to make sure that everyone got the lesson, but clearly everyone's going to get the lesson.